All right. Good morning. Today we're going to cover section 6.8. This is we are going to go 6.6, then 6.8, then we'll finish with 6.7. It kind of makes more sense to go in that order. So if you're watching this thinking I haven't seen 6.7 yet, don't worry about that. You'll be all right. So as section 6.8 is the graphing section where we're going to be talking about how do I graph square root and cube root or third root functions. We're only going to look at those two radical functions. We're not going to look at fourth or fifth root. We're just going to focus on mainly square root, and we'll look a little bit at cube root as well. So as a quick warm-up, just to recap what we do with these compositional functions. So if I have two functions, right? I have f of x and then a second function g of x. And I want to find f of g of -5. Again, the order for that, it's kind of working backwards. So I'm going to take -5, plug it into g. So I'm going to first find g of -5, which is 10 minus x squared. If I evaluate that, this is 10 minus -5 squared is 25, positive. Now notice that minus sign, right, this minus sign stays a minus, and since I'm subtracting positive 25, this ends up being 10 minus 25, and we get -15. Okay. So now again, with the composition, I'm going to take the output of the first function, and that becomes the input for the second. So now I need to find what f of -15 is. The f function tells me to do 4x minus 8. So 4 times -15 minus 8. F of -15, that is -60. Take away 8 more. So we get -68. Okay. So then this value, f of g of -5, is equal to -68. And that's right, again, just kind of working from right to left. If we do the same thing here, remember you'll either see this open circle to show compositional functions, or you'll see the kind of double parentheses there. So this is saying what is g of f of -2? So I'm going to start with f of -2. If I plug that into 4 times x minus 8, f of -2, that gives me -8. Take away 8, which is -16. Okay. Now again, this will be my input to g. So I'm going to input g. Oh boy. G of -16 equals 10 minus x squared. Yep, 10 minus x squared. If I evaluate this then, g of -16, that is 10 minus 256. -16 times itself would be positive 256. Then if I do 10 take away 256, that will give me -246. So that is my value then here. So g of f of -2 is equal to -246. Again, that's just in section 6.6, we looked at adding, subtracting, multiplying, dividing, and then this composition of functions. Let's get into the graphing. So some things that you learned back in, what was that, chapter 3 or 4, is something called the parent function. And a parent function just simply means you're talking about the most basic version of a function. So the version that hasn't been translated or flipped or size hasn't changed. So our two parent functions we're going to look at today are the square root of y equals square root of x and y equals third root of x. And to build the parent function, all I'm going to do is pick numbers that are in the domain of this function that will give me nice graphable numbers. So if you think about what values of x can I plug in here, we know that the domain has to be, x has to be greater than or equal to 0, right? I can't plug in a negative number. So let's start with that value first. I'm going to start with 0 as my first x value, or my first domain value. And if I plug in 0, what do I get out for y? Well, the square root of 0 is 0. And then I'm just going to keep going and choose the next numbers that I know the square root of that aren't a decimal and I don't have to worry about. So the next value of that is 1. The square root of 1 is 1. Square root of 4 is 2. And the square root of 9 is 3. Okay. So if I plot these points, 0, 0, 1, 1, 4, 2, and 9, 3, I get 0, 0, 1, 1, 4, 2. I get something that looks kind of like that. I'm going to draw the arrow on the end because it's going to keep going. I am not going to draw an arrow on the other end of this, right? Most of the time, if you graph something, we tell you to put arrows on both ends of that function. I'm not going to put it on the left end, though, because I can't go any further left on this graph because I can't square root any negative numbers, so I can't go to the left of the y-axis. So these are just the values that I have from the ones I go through 0, 0, 1, 1, 4, 2, and then 9, 3. If we do the same thing with the cube root, what's different here is that the domain now is all real numbers, right? I can cube root any number, positive or negative. So I'm going to take 0, and I'm actually going to put it in the middle of the table because I want some of those positive numbers and some of the negative numbers to kind of get a feel for what that looks like. So if I think the next numbers that I can plug into the cube root and get out a whole number, the cube root of 1 is 1, and the cube root of 8 gives me 2. Then the nice thing is I can just do the negative versions of those numbers. So negative 8, negative 2, and negative 1, negative 1. Again, I'm going to plot these points just to kind of see what it looks like. So negative 8 and negative 2 right there. Negative 1, 0, 0, 1, 1, and 8, 2. I get this sort of this wavy looking graph. You'll see that, I mean, there are some similarities. Like if I were to cut off the rest of this graph, right? If we were to ignore the negative side of things, the square root and the third root do look similar. The difference is the square root's gonna grow a little bit quicker. The cube root's gonna take longer to get to the same heights. But the key difference here is that the third root can go, it goes to the left and to the right from the y-axis because you can cube root both positive and negative numbers, whereas the square root it stops at that 0, 0 point. So those are the two parent functions of the radicals that we're going to look at today. And then we will, what we're going to do from here is take some transformations, and we're going to see what happens when we do that. So one of the first transformations that you learned or that we have were horizontal translations. So again, horizontal meaning side to side, translation meaning I'm just sliding the graph back and forth. One thing that'll be good for you to keep in mind or remember is these basic numbers or these basic points that we used for the square root of x, right? 0, 0, 1, 1, 4, 2. If you can keep those in the back of your mind or just build them, we're going to use those coordinates a lot when we graph this stuff. So I'm going to graph the parent function real quick. 0, 0, 1, 1, and 4, 2. I'm going to go ahead and just kind of connect them, put an arrow on the end there. So there's my parent function. If you see the square root of x plus 4, and the x plus 4 is all underneath the radical sign, we've learned that anytime you add or subtract inside a function, normally when we studied parabolas, that meant inside the parentheses. But here, since that plus 4 is underneath the radical, that means it's going to shift it horizontally. And if you see a plus 4 inside of a function, that means it's moving to the left 4 units. So all I'm going to do to graph this, I could make a brand new table of values, but all I'm going to do is take each of these 3 points that we have, right, 0, 0, 1, 1, and 4, 2, and I'm just going to move each one to the left 4 units. So if we do that, there, and there. So you can kind of see we have the same graph. It's just been shifted to the left. And then on the flip side of that, if I were to do the square root of x minus 1, and the minus 1 is underneath the radical, that means I'm moving to the right 1 unit, again, from the parent function. So from the black, I'm going to move to the right 1 unit for each of these. So I now have these coordinates. Okay. That's not the best drawing, but you can tell. I'm going to actually redo that. Still not great, but you can tell it's the same function. It's just shifted side to side. So moral of the story, if you see a plus or minus underneath the radical sign, that means we're moving it horizontally. Stretches and compressions. Okay. Now this is going to be the I don't want to say the trickier one, but the one that's going to be a little bit tougher to see. Again, I'm going to start with those same values, 0, 0, 1, 1, and 4, 2. Okay, so I'm going to plot the parent function real quick. 0, 0, 1, 1, and 4, 2. Okay. Now, if I want to do 3 times the square root of x, this is we learned, again, back in chapter 4 that 3 represents a stretch, a vertical stretch, because it's vertical because it's outside of the radical. It's not underneath with the x. And since that number is bigger than 1, it's going to stretch it, which is going to make the function taller. You'll notice that 3 is basically, right, this is basically 3 times the square root of x. So what that means is I'm going to take the y values and I'm going to triple them. Okay, so I'm just going to take the y values from the parent function and multiply them by 3. So instead of 0, 0, 1, 1, and 4, 2, these will now be 0, 3, and 6, keeping the x values the same. Okay, so then those are my new coordinates. All right, still have 0, 0. But now instead of 1, 1, I have 1, 3. And instead of 4, 2, I have 4, 6. Okay. So you'll see that, again, same sort of function, but it's got more of an arc and it grows a little bit quicker to start there. On the flip side, again, if we do a compression, this is saying I'm going to take the y coordinates and cut them in half. So instead of now using 0, 0, 1, and 2, I'm going to use 0, 0.5, and 1 with the same x coordinates. Again, all I'm doing is taking these original y values and I'm just cutting them in half. That's how I get the blue numbers. So 0, 0. You'll notice that here with the size dilations, or the stretches and compressions, I am not changing the starting point, right? That 0, 0 is, oh boy, that 0, 0 is part of all of these. Okay, so we've got a vertical stretch in red, a vertical compression in blue is what we call that, because we were multiplying by something that was less than 1. So horizontal translations, so side to side, vertical stretches or compressions, and then finally we have vertical translations. Again, always coming back to that same set of x and y values, 0, 0, 1, 1, 4, 2. to get my parent function. So 0, 0, 1, 1, and 4, 2. 4, 2. Okay. And then I see this -3. If I put the -3, you'll notice that it's not underneath the radical. So that's how I know it's going to be a vertical shift. If I see a -3 outside parentheses, that's telling me I'm going down 3 units. Okay. Another way you could do this, just want to throw that out there. If you didn't have the graph in front of you and you didn't want to graph the parent function first, I would take these points, and since I'm moving it down 3 units, down 3 means that the y coordinates are going to be subtracted by 3. So I'm just going to -3 from each one of these. So 0 would turn to -3, 1 would turn to -2, and 2 would turn to -1. So if you'd rather graph those points, 0, -3, 1, -2, and 4, -1, you can do that. It, again, essentially is going to give you the same thing as just moving each point down 3 spots. Down 3, down 3, down 3. Okay. So there's our translated down. And then, of course, if we see a plus sign, that's going to move up by, in this case, 2 units. So I'm going to just move each one of these up 2 spots, up 2, and up 2. And there's my translated function when I translate it up. Okay, so horizontal translations, vertical translations, and then stretches or compressions are what we're gonna focus on. Okay, so if I have something like this, and this is a square root function that I want you to graph, it's kind of a lot to look at, but here's how I like to do it. Okay, is I'm gonna take. Essentially, what I'm going to do is what I like to do is I'm going to pretend that the translations don't exist. So I'm going to pretend that that 1 and that 3 are gone, and I'm going to start by graphing this. Okay, so I'm going to start by graphing -3 square root of x. So what I'm going to do here is I'm going to start with my parent function. So 0, 0, 1, 1, and 4, 2. Okay, so this is just root x. Then to get it into -3 root x, okay, -3 times the square root of x, we know that that -3, again, it's not underneath the radical, so that is a multiplier to my y coordinates. I'm going to keep the x values the same, right? The domain for both of these is the same. That -3 doesn't change the fact that I can't plug in a negative number underneath the square root because I'm square rooting a negative. So I'm going to keep 0, 1, and 4 for my domain, but I'm going to triple these y values. And I'm actually going to multiply by -3 because that's the number in front. If you recall, a negative number is actually going to flip it as well. That's one thing that I didn't explicitly cover, but we'll see how that works very quickly. So if I multiply those all by -3, my new coordinates are 0, -3, and -6. Okay. So now these are if the translations weren't there, if the +1 and the -2 or whatever the numbers are, these would be I would graph these 6 points. Okay. But now we do have to go back and think about the fact that I had a -1 underneath the radical sign and then the +3 outside. There's 2 different ways to go from here, and I'll show you one example of each just to kind of see. We know that -1 underneath the radical is going to move to the right 1 unit, and the +3 outside is going to move up 3. So what I can do then to move to the right 1 unit, if I want to move this to the right 1, that means all my x values are going to be increased by 1. So x is going to be added by 1 because I'm moving to the right. And then y is going to be, if I want to move up 3, I'm going to take the y coordinates and add 3 to those. Okay, and that'll give me my new set of XY values. Okay. So adding 1 instead of 0, 1, and 4 now, I'm going to use 1, 2, and 5. Okay. And then I'm going to add 3 to all my Y coordinates. So instead of 0, it's going to be 3. Negative 3 turns to 0, and negative 6 turns to negative 3. Again, so I'm just taking the X and Y values from here and adjusting them accordingly to get my my final coordinates, and these are the ones that I'm going to graph. Okay. So 1, 3, 1, 3, 2, 0, and what was the last one? 5, negative 3, 2, 3, 4, 5, 1, 2, 3. Okay. Now the tricky part about this, and it might not be as obvious right away, is remember our graph started at 0, 0, and there wasn't an arrow going from that point. So now the point that we are starting at is 1, 3. So when I plot these, I need to make sure I connect them. Oh boy. I need to connect these things. Oh my gosh. That's terrible. But I need to not draw the arrow going to the left. I'm not going to do this. Okay. Because I can't keep going to the left, because then I am square rooting a negative number. Okay. So there's the graph that we're looking for. You'll notice it is starting high and dipping down, which is what that negative in front does to the graph, right? That negative has that reflection. The 3 is stretched, so it is taller than our standard parent function, and then we've moved all of those points to the right, 1 and up 3. Okay, so that's one way to graph this. The other way to graph it that I really like to do is, again, I'm going to ignore the translations for the time being. So I'm going to focus just on the 2 times the square root of x. Okay, so what I'm going to do is start with 0, 0, 1, 1, and 4, 2. And then I'm going to double the y coordinates because it was 2 times the square root of x. So double this, double this, double this. Okay. So to get 2 square root of x, that's going to be 0, 0 still, because doubling 0 keeps it the same. 1, 2, and 4, 4. Okay. Now here's what I like to do with this. Is that this is going to I know that plus 3 is going to move me left 3, and that minus 4 is going to move the entire function down 4. So what I'm going to do, and this is kind of goofy, if you had me for first trimester, we did parabolas the same way, is I'm going to take 0, 0, and I'm going to move just that point left 3 and down 4. Okay, so I'm going to go left 3 and down 4. I'm going to think of this now as the new 0, 0. Okay, so I'm going to picture it like I've moved the entire graph. So this now is my new origin. Okay, so when I think of 0, 0, I'm thinking of that point right there. And then all I'm going to do is graph these coordinates. So I'm going to graph 0, 0. Okay, but again, that blue point is 0, 0. Then to graph 1, 2, I'm going to go over 1 and up 2. Okay, and then to graph 4, 4, again, starting here, I'm going to go 4 to the right and 4 up. And then just connect those that way. Okay, so the difference between the two is that in this previous example, to show the translation, we actually changed the coordinates. So we added 1 to the x's and added 3 to the y's. Here in this other format, I'm moving where the origin is in my mind. I'm moving where 0, 0, the point 0, 0 is, but then I'm just graphing these coordinates as they stand, just imagining in my mind that 0 doesn't actually start in the middle, but it starts right there. If one way works better for you, great. If the other way works better for you, then stick with that. Again, either way is going to get the trick done. I like this second method personally, just because it is a little bit faster. And if you're okay with envisioning 0, 0 as a different point, then you're good. The homework on 6.8 is from 7 to 19 odds and then 25. So just a selection of problems in there. That'll do it for section 6.8. So congratulations, we're almost done with chapter 6, and we get to move on to bigger and better things.